the Matterhorn. The Matterhorn is the child of two continents.
What's amazing about the Matterhorn is the top pyramid of the Matterhorn is a piece of Africa, and it lies on Europe.
In the formation of this classic mountain, the two continental plates have actually overlapped.
You can think of a car crash. If two cars crash with each other, maybe one car slides over the other one. The two continents moved together, and Africa moved on top of Europe.
Plate tectonics are responsible for all the Earth's mountain ranges. And over millions of years of growth, the only thing that has stopped them grinding inexorably skywards is erosion. Erosion by snow, wind, and rain.
This is the action of water that is eroding the mountains. Now this might seem to be something very small, but actually if you look at the entire Swiss Alps, 50 million tons is eroded every year, and this corresponds to a small mountain roughly 1,000 meters high, one every year.
The height of mountains around the world are determined by these two opposing forces, uplift and erosion, changing them by fractions of an inch up or down each year. But plate movement and water erosion can also create the opposite of a mountain. Under the right conditions, the surface itself can be cut away. Sometimes spectacularly. The Grand Canyon, over 1 mile deep, 10 miles wide, 277 miles long, and still growing.
One of the great stories of exploration is when the first Europeans saw the Grand Canyon in the year 1541. And a couple of those men came over to the rim. They saw the river down below and they thought it was 6 feet wide. The explorer sent a couple of his men down, and they came back later and said the canyon is deeper than it looks.
Wayne Rainey is an expert on this geological phenomenon. Its unique scale, the consequence of titanic forces of nature. Over the course of the last 6 million years, this spectacular canyon has been carved by the slow, winding Colorado River, in combination with dramatic uplifting of the Colorado Plateau. Plate tectonic processes have pushed the whole plateau upwards. It now lies over 8,000 feet above sea level.
This uplift probably occurred with the Pacific plate coming into the North American plate and wrinkling the crust, much like if you took a throw rug on a hardwood floor and pushed it along the hardwood floor. When the edge of that rug reaches the wall, you'll see this big bow up in the rug, and that's exactly what's happened to the western edge of North America.
The river looks too small to cut a canyon so deep, but its height above sea level means that the force of gravity gives it great power.
All you have to do is look at big rivers like the Amazon or the Mississippi. They have much more volume of water than the Colorado River does, and yet they don't cut large canyons because their landscape is not elevated. So uplift brings the rocks into an elevation where the river can then saw down through all of those layers and create the canyon landscape we see today.
Plate tectonics combined with erosion have sculpted many of the features on the surface of our planet. And as a general rule, the most jagged, tallest peaks and the deepest canyons are the youngest of these grand structures, all formed within the last 50 million years. But the final touches have been added by yet another major force of nature. 2 million years ago in East Africa, ancestors of modern humans were taking their first steps on Earth. At the same time, down from the North Pole, enormous icy glaciers began to descend. The Earth was about to enter the Ice Ages.
A comet were to strike the Earth's surface? What if a catastrophic earthquake were to hit New York or LA? Or, say, a giant glacier collapsed, causing monumental flooding throughout the planet? How would the world handle a disaster of such mega proportion? What would be the ultimate result? And most importantly, are we prepared? Now, the History Channel answers these questions as we confront our biggest disasters yet on Mega Disasters, Tuesdays at 10.
2 million years ago, ancestors of modern humans had begun to spread out of Africa. But the Earth around them was cooling down. Before long, much of the planet would be coated in huge glaciers. The Ice Ages had arrived. The grand freezings were triggered when overflowing volcanoes in Panama created the land bridge joining North to South America and radically altered global ocean currents. The polar seas cooled significantly. The result was that pronounced dips in global temperature could now tip the planet into ice ages lasting tens of thousands of years. Iceland. The Lóngjökull Glacier. In the highest, coldest parts of the planet, glaciers still reign supreme. Few venture out in these hostile terrains, but glacier climatologist Finnur Pálsson and his team regularly battle the freezing elements.
When you're doing glacier fieldwork, conditions can be very bad.
Outside, it is below minus 20 degrees Fahrenheit.
I like to work in harsh conditions. Difficulty is something you need to tackle.
Finnur is keeping tabs on the growth of the glacier. At present, it is over 350 square miles, the size of New York City. And although it may look static, in fact, it is in constant motion. Glaciers are formed initially by snowfall on high areas. The compacted ice is then dragged down by the force of gravity. The glaciers move like slow-motion rivers.
You can think of ice as soft material like toothpaste. It flows. If you would make a big blob of toothpaste on a plate, it would slowly sink down and flow away to the edges.
Finnur and his team in Iceland regularly check on the incremental movement of the ice.
This is a satellite positioning system. We can calculate the position of this point with an accuracy of about 2 centimeters. To calculate how fast the glacier moves.
Finnur's measurements tell him that this glacier is moving at over 150 feet per year. In today's mild temperatures, glacial advance is kept in check by glacial melting. But if global temperatures were to drop by just a few degrees for a long period, then the glaciers would grind slowly forward and the Earth would enter another ice age. The existence of ice ages was first discovered by 19th century Swiss geologist Louis Agassiz. As he explored the Swiss Alps in the 1830s, Agassiz couldn't help but notice the immense boulders scattered over farmland and the bizarre towers of gravel capped by stones